Hey, what's up guys? This video here is a little small tutorial on the MKBLs and soldering in general. Some of you guys post that you have BL failures and you're not sure whether if you should replace the entire BL, if you should replace just the caps or actual individual components on the BL itself. And a lot of you are a little bit intimidated or hesitant to solder these kind of boards. So this instructional video is going to show you how to do that. It's rather easy. All you have to do is take your time and be careful. It can be done very easily. So we're going to go over some of these individual things. So let's get started. Okay, so here I have a Sinistar 8 power distribution board that I came out of a crash that I unfortunately had this past summer. And I actually have 3 bad BLs on here. So we'll go over, I'm going to use this board to actually replace one of the bad BLs. And we'll go through it step by step. So the first thing is, what I do with here is when I have this board hooked up to my power supply. I got DC regulated power supply, and I just got 15-16 volts going to the power distribution board. And as you can see here up in the close-up shots, the good BLs are red and green, and I have a couple that are actually not lighting up at all. So I know for a fact that at least the caps are bad. So what my main thing is that I would like to tell you is that some of you ask, can I just replace the capacitors? The answer to that really is, my opinion, no. It's kind of really foolish to go through all this, taking the board off the copter and doing all this soldering and just to replace a cap, because you might as well get a brand new BL. If something's wrong with the BL, or something's wrong if you have a bad capacitor, you could have a bad capacitor and another bad component on there as well. Maybe both capacitors are bad. You just never know, and it's just a lot easier. These things are relatively cheap. They're 60 bucks, and I just recommend replacing the whole entire BL. When you do get a BL, they do come with 2 new capacitors. Let's talk a little bit about what to purchase, what to use. I've been a broadcast technician for over 20 years. Been in the AV field as a VHS technician, broadcast technician, video engineer, and I've always grown up on Weller products. Weller products has worked very reliably for me. I really like them. For many years I just used a Weller W60P, and that's a 60 watt iron. That worked very well for me. It can work very well for you too, but the only thing about that is it's not an actual station where you can control the temperature, which is very helpful in these type of applications, what we're going to be doing. So I really strongly recommend either going with 2 different types of setups. Go with a Weller electronic station that actually has variable control where you can actually set the temperature, or thanks to the guys on the Free Fly board, they recommended the Heiko FX951, and I've been using that now for about a couple months, and I really am starting to go away from the Weller now. I really like this product. The temperature is very solid, has a lot of great features on it, and it has a wide range of tips that you can use. So that's what we're going to be using when we're going to solder this BL together. So we're going to use the Heiko, and for Heiko tips, I primarily have 2 tips. I'm using either a T15 D12 or a T15 BLL. The BLL unit, it has a very fine tip, and that's great for what we're going to be soldering today. So that's what I have in my station, and we'll get going. Another important part of soldering is setting the solder iron tip temperature. Um, you know, I've read all kind of different things where people say to do this or that. I really do not feel there is one good right answer. What I can tell you is I think that there is a very good range to run your temperatures at. Anywhere from 625 to 750 is pretty much will be fine. I personally like to run my tip temperatures for at least 700, 7 to 725, and I usually do not ever touch it, and it's just usually right there. Now, what's important to know about tip temperature is the higher you run it, you have to know that it can damage your boards quicker because the temperature is going, you know, that's the temperature of the tip that's going to be on your board. So what the advantage of using a high temperature is that it can melt the solder quicker, and you should be theoretically on your tip of your soldering iron should be on the electronic board, the soldering pad, less time. So that's the theory behind that, because it's always the longer your tip is on either the component or the pad, the easier it is to rip it, to damage it. That's what heat is what damages components. Heat is what damages solder pads and lift solder pads and traces even. So you want to be able to stay on the solder, whatever you're soldering, you want to stay on it as minimally as possible. So the idea is to have the solder melt quicker, and you need to do what you need to do and get it off as quickly as possible. So I like to run that. I mean, I've seen other guys run, you know, and solder at 600, 585 and able to do it. It does take longer for it to build up temperature-wise and it takes longer to melt the solder. So, you know, you might want to experiment with that a little bit, but I really don't think you can go wrong with anything around 700, provided you use it with caution and you don't stay on a particular point more than 4 seconds or say. Okay, so here's the BL we're going to replace. There are 6 pads, 6 connections that we have to desolder to take off the existing board. Taking off the existing board is about 85% of the work here. You have a C and D pad right here. They will have to be desoldered, and then you have to this is a cap right here, and this is a cap right here that we're going to desolder. So this is what's called a solder sucker. So this will allow it to use this vacuum and actually sucks up the solder. And this is what's called a solder wick. And you put the wick on there with the tip, and that allows this right here will actually absorbs the solder as well. Sometimes a solder wick can be helpful, and sometimes a solder sucker can be helpful. The problem with the board here is that you can get solder in between the boards. See right here, this is a heat sink right here. Let me zoom in. Okay, so the hardest part about removing the BL from here is that in between the heat sink and the BL and the backside of the BL, backside of the heat sink, you can get solder in between here. And that little bit of solder sometimes is really difficult to get out and to remove. So I'm going to show you a couple things that I do, and we'll start on it right now. Here is the C and D pads. Again, I'm going to put a little solder to them before I remove it. And I'm going to turn the board over and get the rest of it on the other side. So now you can see there's a gap right here. See if I can see it right. You can see a gap right here. Now that'll allow me to be able to, I'm going to start pulling the board through to get them off the pad. Okay, so now the C and D pads are free from the board. Another trick to remove these caps is, what you want to do is you want to heat up the solder pads from the other side of the board, and then what you can do is you can pull up on these leads right here. So what I actually do, which has worked very well for me, is I actually like to cut the cap off, cut the leads off the cap, and then, so I've actually removed the cap. And then what I'm going to do is I'm going to heat up the bottom and then pull right here up with the needle nose and pull these leads through. And then I will remove all the excess of solder. What I'm going to do is I'm going to try to get all of as much solder off as I can off of these leads right here before I start trying to pull the leads through, or try to take the board off of the main power distribution board. Okay, so here I have 3 of the 4 legs broken off, and I just have this little bit hanging off the board right here. So that I'm going to put some heat to, and then just pull away the lead. And as you can see, even with a very good soldering iron, sometimes this solder isn't that easy to remove. So I'm going to clean my tip again, get some nice heat, tin my tip. And get some good heat going on that joint. There we go. The old BL is off. So now, what I have to do is, let me see if I can go ahead and show you this. This is, right here are the holes for where the caps are going in. What I want to do is I want to make sure all of the residual solder is off of those 4 pads so that I can get the new capacitor to go through there. So right here where my screwdriver tip is, I had a bit of a problem getting all the solder around that pad off enough where it'll allow me to be able to put a new capacitor through. The only way I could get it really to get that amount on is use the solder sucker. And again, I know Microcopter recommends not using that, but that for me, that's what I needed to do. So now, before I put the new BL and capacitors in, I'm going to clean up the board a bit, and I'm going to use a little bit of isopropyl in conjunction with a little toothbrush. Okay, so I'm ready to solder these capacitors to the board. So I'm going to tin my tip, get a nice flow going. I stay on these pads a little longer because solder does flow through to the other side. Okay, so now I'm going to trim the leads, and then what I'm going to do is I'm actually going to save these leads when I trim it, and I'm actually going to use the legs of the capacitors I'm taking off to use as a bridge to connect the C and D ports. See right here, you can see that. Let me try to put that on the camera. How I can put that on the camera. The C and D ports on the BL needs to be connected to the actual power distribution ring board. And I'm going to do that by using these little legs that I just took off the capacitors. And then I'm going to do is I'm going to bend it both ways like that so that I have a good solid connection, and I'll trim it when I'm done. So one last thing that we have to do with the BL is there are 2 pads here. One has numbered 1, 2, and 3, and then the other one's 4 and 5. Depending upon which BL, you have to assign it to that number. So for example, we just did number 5. Number 5 has number 4 and 5 shorted together. So right here, we're going to make a solder bridge between 4 and 5. Okay, so last thing, hooked up my leads again, put power back to the board, and my BL's back on. So we're good to go there. So now after, the last thing I'm going to do after I'm done with all my soldering is I'm going to clean the board really good. I'm going to use toothbrush, isopropyl alcohol, and just do a light scrubbing all over all my solder connections. Because when you do soldering, you might have just a little bit of solder splatter that just goes somewhere where it shouldn't go. So I like to do that and just to take precautionary measures. So I'll take my toothbrush and just lightly clean the board. So I'm going to go all around both sides, scrub the board really nice. Last part of this that I can't implore you enough is that you got to invest in one of these things right here, magnifying glass with a light. I'm going to go ahead and look at the board, and it's going to really show me every tiny little detail, making sure nothing's missed, nothing got splattered somewhere, no solder bridges where there shouldn't be. This probably, I'll go through this for a good 20-30 minutes on both sides of the board, and then that allows me the alcohol to dry as well. I give the isopropyl alcohol probably a good hour, at least an hour to dry. Then I'll start putting, back on the copter, give it some more time, and by then everything will be nice and dry. And then I will also, in combination to this, I'll use some compressed air and just go ahead and give it some more, clean it up just a little better. So that's really it. All you got to do is take your time, and there's really no reason why you can't do this. Again, the most important thing is not to put too much heat into the board itself. The microcopter boards are easy to damage, but don't be intimidated by it. If you've had some soldering experience in the past, there's no reason why you can't do this with the right equipment. And even if you haven't had any chance to have or experience with anything, if you can find something used that you can go ahead and practice on, get a feel for it. Even if you've an old BL or anything that you have laying around, you can start practicing soldering. And that's it. So I hope this video has been helpful, and I'll see you next time.